Hi, welcome everybody. Thanks for coming to our webinar. My name is Sarah Lynch. I'm the marketing manager at PSIM, and today we're going to talk about the license options that we have in stock for our academic customers. But now, without any further ado, I want to introduce our presenters or guests here today. I have Shannon Chesley. She's our sales manager. Hi, and I have Albert. He is one of our applications engineers, and most of you probably know him as our normal, usual entertainer at our webinars here and our technical expert. Yeah, now some of you might not know us yet. We are from PSIM. PSIM is a power electronics solution provider now since over 25 years. We provide tools for design, simulation, and implementation of power electronics, motor drives, and microgrids. The company started with our flagship product, which was PSIM. PSIM developed from a power electronics circuit simulator to the most versatile, fast, and accurate simulation tool on the market today. But you see here on this slide that there's a couple other products that we have in stock, which one of the very exciting products here is DSIM. We just came out with DSIM as a brand new product this year in July 2020, and it is specialized for large-scale power converters and microgrids. But DSIM is not just some generic tool. It is actually the fastest solver in the world. So you won't find any faster offline simulation solver anywhere. DSIM is a separate product, but it can also be used together with PSIM in one software or as a standalone software on its own. The third product here on the slides that we can see is SmartControl, which is a software for digital and analog control design, and we have PExpert. This is a hardware product, and it is a digital development platform dedicated to advanced power electronics. And yeah, with that, you see all of our products that we offer here at PSIM. And now we want to talk about why are we here. So PSIM sells its products to industry and academia, and it is very important to us that our academic customers have access to first-class tools at rates that fit their budget, because we know that academic people, students, professors often have very limited budgets, and it can be difficult for them to purchase some certain solutions. So depending on your needs, we offer free as well as deeply discounted paid licenses to students, professors, and researchers. So that's why we're here today, to see what options are there and how much do they cost and what do they include and what not, and what can I use them for. So all of this we're going to look at here today. Here's a quick and simple overview over these three different options that we have: the PSIM Demo, the PSIM Student version, and the PSIM Professional license. This is a simple overview. Let's look at a little bit more complicated looking one. Here you can see there's also a link, so later when you get this you can go to our website and look into this more closely, but I can also zoom in here a little bit. And yeah, maybe Shannon, can you tell us a little bit more about this table and what we're looking at, or where should we look?
Sure. So to start, as we saw on the slide previously, there's the demo version, the student version, and the professional version. So here you'll see like the free demo and the student version have some limitations. We'll go into those details later. PSIM Professional, there's 3 columns actually that deal with PSIM Professional. There's the 30-day trial, which is what you would use for an evaluation to purchase a license. And also PSIM Professional has the last 2 columns, which are, if you look down at the bottom, there's the license term row, which lets you know whether it's a 1-year subscription, or the last column is the permanent, the lifetime license. And this table kind of summarizes the limitations for the demo and the student again, and what's included and what's optional in the paid licenses.
Okay, that sounds great. Let's maybe just dive right into the first license option here, which is the PSIM Demo. Shannon, who is gonna use this demo, or who is it gonna be
Sure.
useful for?
A lot of students, especially undergraduate students, professors are having them download it for, teaching needs, or just anybody who wants to kind of get familiar with the software before they start using it on a job or just in general.
Mm-hmm. But it's not just showing the software. You can actually do some work with this?
Yes, yeah, you can. I mean, there is a limit for the number of elements you have in a schematic, but I mean, there's hundreds of elements available, and there are limitations for simulation, but you can use it to do work.
Okay, cool. Albert, can you maybe show us an example of what can be done with this demo version of PSIM? What kind of application?
Sure can. Let me share my screen.
Okay.
And yeah, you should be looking at the right screen now. You should see that.
Flyback converter.
Yes, great. Okay, so this is a simple little circuit. This is just one of the demo circuits. So if you run it, there's kind of two major limitations with the demo. One is component count, and then the other is the length of, that's running in my, sorry, I've got, that ran in the wrong engine. Okay, here we go. So if I run this in the demo, pops up. So it's told us that the number of data points in the demo version is 6,000. So that's the number of simulation points were allowed. So it's truncated it, but we can still look at the results. So we can see we've got 120 microseconds worth of simulation time, but I had asked for 5 milliseconds worth. So with the regular version, you'd be able to get the full 5 milliseconds, but with the demo, we're truncated at 120 microseconds. So that is a combination of time step and total time simulated. And then you can see how many elements you're using. So you can do element count, and we can see in this, there's 10. So the element count limit is 34 or so, or 34 for the demo. So, you could do something like this as well. So this one has a number of more elements, and we can see that this one is running, and it'll show up some waveforms there as well. And so this is just the sort of thing that the demo has. So it's allows for some simulation to be performed, but definitely, sort of undergrad learning power electronics type, simple bust and buck and boost converters will be okay. But otherwise, anything more complex, and you're going to need to move to a different package. That's all I got to say.
Oh, okay. Sounds pretty good. But it's interesting to see that this is not just a demo, but you can actually do stuff, and it's free. So
yeah,
what more can you ask for?
Exactly.
So I'm gonna take back the presentation here. Can you guys see the presentation again?
Yes.
Okay, good. Then let's get to our next license options, which is the next tier up, a student license that is also called free teaching license. Shannon, why are there two different names for the same license, and what are the differences?
Sure. So they're both the PSIM student version. So the student version increases the element limitation to 60, and it takes away the simulation restrictions. The PSIM student license, you can buy it. An individual can purchase the student license. It's a lifetime license, like it says here, $99. Also, the free teaching license is really just to distinguish the license that a professor or teaching assistant from university can request every year if they want to have it renewed, and it's free and available for teaching.
Mm-hmm. So the difference is really just how long the license is valid and the price.
Right.
Mm-hmm. But functionality is the same.
Same
Albert,
functionality.
yeah. which kinds of applications can be simulated here with this license, and where are the limitations compared maybe to the demo?
So so with this one, there's a higher component count, so 60 elements. So you can do maybe a slightly more advanced power supply with a few more parasitic elements involved. There's no limit to the number of data points, so definitely you can run longer simulations and do studies that way. There is no nonlinear models, so like nonlinear magnetics or nonlinear machines, and you can run a machine system. So I would say kind of the upper limit of complexity is a closed loop motor drive. So doing like DQ control, field-oriented control on a PSIM is kind of the top level. But if you wanted to get into nonlinearities, you need to be moving to the next level up. And then you also can't run the thermal module as well, so you can't look at the switching and conduction losses.
Mm-hmm. Okay, cool. All right, and here we're already at the third license option, which is the last but not the least, of course, which is PSIM Professional. And as we can see here on the slide, there's 2 free options and a paid options. And since free sounds always like a pretty good deal, let's see how this works. So maybe Shannon, can you talk a little bit about this free trial and what this is all about?
Sure, yeah. So the free trial, again, there's no limits on it. It's PSIM Professional. It includes all functionality. All libraries are open, no limits other than 30 days. And it's used for an evaluation in anticipation of buying a license.
Mm-hmm. Okay. Okay, and then the second free license that we can see here is the PSIM sponsorship license. And I can tell you a little bit more about this, because if you request this, your request is going to come to me, and I'm going to try to help you out with getting a free license. This is also a full-blown PSIM license with almost all the available modules and functionality included. But only official teams that are registered for an official design competition or a challenge are eligible to apply for this license. So not everybody can just be sponsored, but we do try to support these teams that are having these projects where they work on a certain, most of the time, motor control or certain converters, and yeah, we try to support them. Examples for eligible events that we have supported in the past are here seen on the right, which is the Formula SAE event, the Formula Sun Grand Prix, SpaceX Hyperloop Pod competition, and the Shell Eco Marathon. And when a team applies and qualifies for the sponsorship license, we will be in touch throughout the whole competition and like checking in if you guys need any help, or if there's anything that you can share with us already. And in the end, we will promote their work and work together on some content so that we can show the efforts of this team. So this is really a win-win situation for those teams. And we have had some really, really talented engineers who were super happy to use this license. So please, if you are part of one of these competitions, reach out and we will be happy to help. Yeah, but then of course we can also, and that's good for us too, to pay for a license, like a paid pro license. And everyone in education and research can purchase one of those. Shannon, can you tell us a little bit more about this Education Pro package?
Sure, yeah. So a few years ago, we redesigned our academic options to support our customers, and we provided a lot more combined functionality and users at a lower cost. So Sarah, can you switch to the next slide?
Oh yeah, sorry.
Thank you. No, it's okay. So PSIM Professional, like I said, it includes all this functionality now, and also it includes the integrations you see here with Simulink and RidleyWorks, Typhoon Hill. So that's the Education Pro package. So whether you subscribe to it, every year or buy a permanent license, this is the package.
Mm-hmm.
I'll just chip in here.
Yep.
The Ridley Works link also links back to this free teaching license. The outputs from Ridley Works also run on that tool. Well, I'd say most of them do. Ridley Works has some options that add like extra filters and extra kinds of bells and whistles, and those won't run in the standard. You hit the component count, but in general, most of the outputs from Ridley Works will work with the free teaching license.
Mm-hmm. Okay, but this is a little bit limited to these certain package modules. What other options can be added to one of these licenses?
Sure. Yeah, there's some other optional add-ons you can do. You can link with Spice. You can add the SIM coder package to PSIM, which is for embedded code generation. There's links to other software like JMag or ModelSim you'll see listed here. And of course, we do have some other software that we started off. We mentioned there's DSIM, so you could, in tandem or by itself, you could purchase PSIM and DSIM and or SmartControl.
Okay, so this is now already the second time we heard about DSIM. Maybe we should tell our audience a little bit more about what DSIM is, what's the difference to PSIM. Albert, can you maybe enlighten us about this a little bit?
Right. Okay. So the main thing to comment on with DSIM is that it's a new engine, and therefore its application space isn't its full breadth yet. So right now, DSIM is best used for large power converter simulations and microgrid style simulations. The converters with DSIM need to be digital control or open loop, so it won't work with sort of like analog control or peak remote control or something like that. So if your simulation runs in DSIM, it'll be 100 to 1,000 times faster, or even more. The speed of simulation kind of increases with compared to competitors or PSIM or whatever other tool as you add more switches in. So PSIM is a general purpose power simulation tool specifically designed for power electronics. DSIM may eventually end up kind of almost like that, but it's not there yet. We're still adding models, still adding functionality. The recent release added updates, added a few more machine model types and all that sort of thing. But yeah, so PSIM definitely will be able to handle anything and everything you throw at it. DSIM will be able to do certain things a heck of a lot faster than anything else, as long as they kind of fit within its functionality envelope.
Mm-hmm. Okay, so we have here also like a little bit more information. When you get the slide deck, you can look at what DSIM can and cannot do yet. But of course, as well as PSIM, DSIM is also being developed further every day. So just keep on top of the versions, and yeah, DSIM will eventually have much more breadth of
Functionality.
Functionality, application space. So, and since we talked about DSIM, we might as well also talk a little bit about SmartControl. What is this used for, and why is it a good tool to use?
So SmartControl, if you've watched any of the tutorial videos that I've done that do power supply design, or come to any of the webinars where we talk about closing the loop, SmartControl is the tool I use. It is a graphical design tool. It plots a stable operating space for you with regards to cross-frequency and phase margin. So it shows you graphically what relationships you can have when you design a PI controller, a Type 2 or a Type 3. You can work off a generic topology, or you can import your own frequency response. So you can even close the loop on things that are not power converters. So if you have any frequency response and you want to design a controller for it, you can go from there. It's fairly robust. You get, once you are familiar with how it works, and you can start doing things like defining equations for custom controllers or doing all sorts of other things. But it's definitely a very easy to use graphical control design tool. And as you tune your controller, it shows you the Bode plots for the loop gain transfer function and for the and it gives you a step response estimation. So it's a fairly powerful tool. And as I say, most of the tutorial videos that cover power converter design use SmartControl, so you can check it out there.
Okay, cool. And since we've talked about these tools, can we maybe see them in action in the demo of our Pro package?
Sure. Yeah. Let me share screens. Okay, show my screen. You are looking at the right one. Perfect. Okay. So the first simulation I'll show is a look at our motor control design suite. So this is a good simulation for that can be done with a Pro package. So we have a PSIM drive here with an inverter. We've got field-oriented control. We've got MTPA and an MTP max torque per ampere control implementation, field weakening. Let's just run the simulation. And we can kind of watch what's happening here. So this is going to ramp up to 2,000 RPM, 3,000 I think, and then it will stabilize out. We can look at some currents here, BC. So that we've got the drive currents. But yeah, this is the kind of thing we can look at. Obviously, this is a much longer simulation than the ones that we were looking at with the standard or the demo version. You could run this with standard license. I definitely couldn't run with the demo either. But the nice thing with this is looking at the design suite. Basically, what happens here is it gives you a starting point for a motor drive simulation. So you put in your motor drive parameters, and then when you hit update parameter file, it will open up and calculate PI controllers for DEQ and speed loop. So this is part of the base Pro education package.
Mm-hmm.
Yeah, I'll just stop that. We don't need to go to the end there. You kind of get the idea. Yeah, so here's ID. There's the IDs. And then there's the IQ controllers working. So there's a couple. There's the field weakening region that we see here. So we're regular, max torque per ampere up the top here. Switch to field weakening in the middle, and then back to steady state over here. Another simulation to look at is cogeneration. So this is part of the, actually I'll run the MATLAB simulation next. So the other part that you can do here is you can co-simulate with MATLAB or Simulink. So here's this motor drive in Simulink, and this is the linked block here that points us to, if I double click. So this points us to the schematic. Oh, okay, here we are. So this is the schematic that's going to open. So this is what is happening in PSIM. So PSIM's handling the drive, the inverter, and the motor. And then you can see these nodes are passing information into and out of Simulink. So we can run this, and it will run. So here we go. And this is going to be a bit of a longer simulation than if you had everything inside of Simulink, or if you had everything inside of PSIM. So definitely trying to put as much of your circuit inside of PSIM is going to give you a faster simulation for sure. But you can, if you're running into convergence issues with Simulink, or you want to use one of like our nonlinear models or whatever it is, you can definitely link in with this way without having to redo your whole control system that you would have had in Simulink. Yeah, so we don't need to watch this one to the end either. Get the idea. And then another one, and then so yeah, at the end of it, you can look at the results in either PSIM or in Simulink. And you can path the variables between the two, so you can path the variable from Simulink down into PSIM or whichever. Okay, so I'll close that up. Okay, now we'll look at the cogen. So this is a look at our cogeneration. So this is a three-phase inverter with DEQ control. We can simulate this. So this is the important part with our cogeneration, is we can simulate these and we can look at what's happening when we run the simulation. So we can see this going, and we've got these code generation elements in here. So you can see this one's for the 37X target, the PWM block here. And if we launch that open, we can see the options we're given here. So dead time, switching speed, interrupts, ADC triggering, all that kind of stuff. So this is all inside of here. And so what we can do is, let me just change the name of this to academic. We'll change that one. We'll go change this one to underscore PSIM. So I will simulate and generate the code. So this is the C code that gets generated. We're defining this, and it's not just the C code. We're generating a full project. So you'd be able to look at generate folder. So basically, there's tons of webinars on this as well, but we basically just import this project into CCS, and we get to go. But the C code that gets generated allows you to easily use these processors, and I was just going to kind of highlight the way the C code works is if we look at this task, we're fetching the ADC results right here, and then you can see F academic, this line right here. It corresponds with this block here, which is the AC alpha beta transformation, and we can see the math for this is brought out right here. So, and then I also changed the name of that other one to FPSIM, which is here, PSIM, and this is doing, that one was the DQ to alpha beta transformation. So every element in the schematic ends up with a variable in the code. The code is as efficient as your schematic is. The function calls and the updates of all that kind of stuff is fairly compares very well to the base T-line projects that get built. Yeah, so that's with regards to PSIM. Do we have time for me to show a quick SmartControl example, or should we?
Yeah, no, please.
Sure. Okay, we'll open up SmartControl. So SmartControl, again, we get this pop-out window. We can design, here if I get my little drawing tool going. So these ones are generic converters we can work with, sorry, predefined topologies, or we can go off something generic down here. Erase all drawings, go back to pointer. So let's just work off of a single loop converter here, and I'll just load up the basic system here of defaults. So the whole idea here is that we're working off of a transfer function for the plant, a transfer function for the current sensor or the feedback sensor, be it voltage or current or whatever, or speed or whatever you're sensing, and then your compensator. And so then you click an operating point, and then as you're inside that operating point, we can see that it's stable. And if you go outside of that zone, you can see that you end up in bad news bears territory. So you can pick your operating point, and then this links to PSIM. So you can export this to PSIM. Let me just put this on my desktop. And we'll go this way. So here's our, I'm not sure, those were the limits for the, yeah, let's just go minus 1,000 and 1,000. All right, so there's our current control. I could have done a better job picking an operating point, but you get the idea. Mm-hmm. And yeah, so that's SmartControl in a nutshell. So you can work off of the built-in topologies, or you can the way I do it in the tutorial videos is I import a frequency response. So in PSIM, if you go to help video tutorials and you check out the power supply design videos here, all of these show the use of SmartControl in a generic fashion for any, regardless of what the power stage would be. So you can just import the frequency response from PSIM into SmartControl and devise a controller that way. Analog and digital control is handled. That's all I got to say about that.
Cool.
Yeah. Okay.
Is that
No
the
more.
end of your demo?
I don't. Yeah. I don't have any more. I don't have any more demos to show unless someone has a specific question. I could do a DSIM simulation if someone was interested. Do we have time
Yeah,
for
can you
that?
show something how quickly that goes? Because we claimed earlier that this is the fastest solver in the world. So I guess we cannot just say that and not show anything.
Yeah, proof's in the pudding, or proof in the pudding is in the eating, or whatever the expression is. Shannon, I know you know what it is directly.
I don't know.
Yeah, so let's, yes, you should see my screen still. So let's look at, yeah, a big simulation here that I know takes a decent amount of time to run. Examples, here we go. Oh, yeah. So we can run this one. So this is a 50 kVA solid-state transformer. And that's done. So that was 100 milliseconds worth of simulation done in just under a second. We can see there's a number of 24 switches in the simulation, all switching at different speeds. And then what else can I say? Yeah, we can go back. And the other strong suit of DSIM is the transient models. So we can look at the switching transition in detail as well without too much of a slowdown. So this is really also very impressive. So now we're running detailed models of the IGBT, the silicon carbide MOSFETs here, and the IGBTs back here. So the parameter set here is pretty broad. I won't go into it. There's other things to talk about, but we're looking at the exact transitions now. And we can see we're looking at, in the inverter, we're seeing this current overshoot and this voltage overshoot as well. We can zoom in and see a little bit of ringing on the voltage, and we can see some other things going on here as well. So this is now showing us the transient response based on whichever device model we wanted to work with. And that was only, so when I'm on a web conference, they're about twice as, they're 2 times slower. So this 15 seconds on a web call would be 6, 7, 8 seconds without anything else going on.
And how long would that take in PSIM?
For 100 milliseconds with detailed switch models, you would be looking at the better part of 2 to 3 hours.
Okay, that is quite a difference. Yeah.
It's quite a bit faster. So this one was benchmarked also with Sabre, and this one was 720 times faster than the equivalent Sabre simulation.
Wow. Okay, that's pretty interesting. Yeah, if anybody wants to see more about DSIM, we have a handful of webinars about DSIM and also some other content on our website, so please feel free to check that out. And let's go back to our presentation here. We have talked earlier that there is different license terms in sense of like length of that. And if you buy a permanent license though, how do you get the license updates, for example, or new features that we develop for PSIM? Shannon,
Sure.
how would that work?
Thanks. Yeah, no problem. So with the subscription, it includes updates to the software through the length of the subscription and all the benefits of maintenance in general. But for a permanent license, we include for 1 year free the maintenance package, and then you can optionally renew your maintenance or not. If you own a permanent license, it's still yours forever. But if you do opt into the maintenance package, I'm happy to say a lot of our customers do renew every year, because not only does it give you the updates to the software to keep your software up to date with improved functionality, but it has a lot of other benefits that we have listed here. For academic users, I would say one of the key features to take advantage of for maintenance is webinar training. So, for example, you might have, a new group of students starting out with simulation or new to PSIM in general. That's a great webinar to set up. Also, if you had maybe a graduate class or a research group working on a new project. A webinar training would be great for them too. So yeah, it shows what the options are, but the training and the updates are really, it's the best way to stay up to date and the most cost-effective way to stay up to date on the software.
So it's cheaper than just buying a new software later, right?
Correct. I mean, we do offer discounts if somebody upgrades from an old version to a new version. So right now we're in version 2020. If somebody had version 11 or version 12, we offer discounted upgrade options, but it's always a better, more cost-effective, cheaper option to have been renewing your maintenance. So the maintenance will keep you up to date, better than buying a new license or even better than the discounts for upgrading, yeah.
Mm-hmm. Okay, so now we have basically talked about almost everything, especially when it comes to the software side, but we have seen earlier in the webinar that there's also some hardware that we provide, and maybe some people are curious about, for example, the P-Expert 4 system. Like, what is this really all about? Why would I need this? Albert, can you tell us something about this?
Yes. So the PSIM 4. You want to flip slides? Yeah, there we are. So we can see the big box thing here. This is, what it is there's a DSP inside of there. That DSP is a TI high performance C6 series, so it's 1.25 gigahertz clocked. If you're familiar with TI DSPs, they're older Delfinos are clocked at 20 megahertz. The newer Delfinos are clocked at 200 megahertz, and so this DSP that's on here is a 1.25. So about 100 times faster than the 335 and about 10 times faster than the newer ones that's in there. And so then that controls or talks with each of those cards you see there with all that are slotted in there. Those are FPGA based, and those do provide PWM outputs, provide analog inputs, provide digital inputs or outputs. It can be configured to meet whatever kind of requirements you have. So the number of PWMs you can get up to is about 144 PWMs optically isolated or without isolation. We provide an option to optically isolate if you want to. You can do a large number of analog inputs, a large number of analog outputs, a large number of digital ins, digital outs. It all depends on what you want and how you configure it. We should kind of talk about the kind of pricing you should expect for this unit. So like a basic version would be 15 to 20,000 US. Slightly more advanced would be 25,000-ish, 28,000 US, and something with all the bells and whistles could be 35 to 40,000 US. So that's there are some discounts for academia. But yeah, that's the kind of the baseline numbers one would expect.
But you need this for certain applications, right? To actually do good work.
So you can do, so if you get one of the really kind of lower model ones, one of the advantages with this is that there's a second DSP involved where you're able to look at all of the control variables. So if you've got internal computations going on or you want to look at the analog feedbacks, you can look at those with high bandwidth, so 100 kilohertz sampling. So you can look at a number of signals with high fidelity. And then, so if you wanted to do basic motor drive control and algorithm verification, you could use this. MyWay sells a whole host of power stages that work and integrate with this unit. But if you're trying to get into multi-level or larger systems or controlling multiple inverters at once, as I say, we can get up to 144 PWMs. In 18, 24, and you get them in chunks. This would kind of be one of the best options for that if you're going into NMC or multi-level. It provides you with the large numbers you need. It's the mixed DSP FPGA approach. And then it's all code generation compatible from PSIM. So you're not having to sit there and learn how to program a Xilinx FPGA. You don't even have to know how to do C code very well. You just lay everything out in PSIM, you hit generate code, exact same kind of workflow as I showed earlier, and then you just hit upload and you're kind of off to the races, as they say.
Oh, pretty cool. And you mentioned DSP boards, and what we haven't mentioned yet is that we also sell a DSP Development Board.
Yeah, so let me just grab mine over here. So this is the DSP Development Board that we sell. It's got the DIM 100 slot in the middle for the TI control cards. So you can put your DIM 100 based TI control card in here. The newer Delfino processors have a different footprint, so we might be revving this soon to accommodate those. But basically, this is a nice little development board for inverter control. You need to provide your own power stage, but we level shift the PWMs for you. We isolate the digital inputs and outputs, and we buffer the analog feedback signals for you on this thing. And it's got built-on JTAG as well, so you can, so there's CAN bus ports, JTAG ports, built-in JTAG. Basically you can get going pretty quickly with one of these, as opposed to something like the TI development kits. So this is like a TI development kit with a power stage already. So this would force you to use this power stage, where this you can build your own power stage and just have it do what you want.
Cool. Yeah, and with that, you have really all you need to simulate and design power electronics converters and motor drives and microgrids, right?
Yes.
So, okay, cool. And now the big question that probably a lot of people have is, what does this cost? Like some of these license options, we've seen some free ones, but we have seen that, of course, there's some that you need to pay for, and we have very great discounts for academia compared to our industry prices. Shannon, can you give us a little overview and maybe an example of some price application?
Sure. Yeah. So, I mean, here's a pretty simple table where we put together some pricing just to see in a quick table format. So we talked about the PSIM student version, and that's available, like we said, for free, or somebody can purchase it for $99. That's the standalone price. There are sometimes universities that will purchase a student license in network for their network, and they purchase that as a permanent license instead of renewing every year. So there would be cost steps up for the network, but not too much. We really have some good discounts when you add users, which we can see here. So the annual academic license, again, is a subscription, and it starts at $300. That's the Education Pro package that we talked about. That's the standalone price. And then the third column is the education package, standalone, the permanent license. It starts at $1,500. I should say that this is all US dollars. And then just the last column gives you an example of if you were to purchase a 5-user network. Adding all those users is just US $2,600. That's the permanent price as well. Anything else? Yeah.
Column, so annual academic is the same license as the PSIM Pro, so the middle two columns are comparable licenses, just that one is the subscription base?
Yes. So the annual academic license is just a fancy name for our annual subscription of the PSIM Education Pro package.
Okay.
So it's all the last 3 columns are the PSIM Education Pro package. Annual academic license is the 1-year subscription of it. And then the last 2 columns are the permanent licensing. We should have had a column, a row for example, if you wanted to add on the SimCoder package to this the standalone price would be $500. So you can see if you were to add it to the academic lease, the subscription, it would only be another $100 to add SIM Coder package to it.
So with the code generation package, does that include all of the targets? Because I know with industry we kind of
yes.
are
So
separate.
for education, yes, it's a good question. So for education, we try to package functionality together. So when an academic customer buys the SIM Coder package, it includes all of the targets that we support, with the exception of the PE Expert 4 target. That's a separate, but all the other TI C2000 targets that we support is included in the SIM Coder package. I guess the only other thing I would say would be that, I mean, if anybody wanted a quote, we are happy to work with somebody to find out what their licensing needs are, what their functionality needs are, and offer suggestions to what they could get for a license.
Mhm. And are the prices the same worldwide, or?
Sure. So the pricing in generally is the same worldwide. The pricing may vary a little bit in your area. And of course, the disclaimer is the pricing is subject to change at any time. But this is our pricing, and it has been pretty much our pricing for the past few years. We've greatly discounted from what we even had before. It was already discounted, but this is discounted more now too and packaged together. And so it's pretty good.
Great.
So there's a question about maintenance.
Mm-hmm. Is there any maintenance payment for lifetime package?
Oh, sure. Yeah. So like I said earlier, the lifetime, the permanent license comes with 1 year for free of the maintenance package. And then you can choose to renew that maintenance or not. And the cost is a 10% calculation on the licensing of that year. So if somebody had a license right now of the 5-user network, I'll use the last column as an example. So if somebody had a license of the 5-user network of the Pro package of $2,600, if they wanted to renew the maintenance next year, they would pay $260.
Mm-hmm.
So, but then also at the same breath, if you get the 1-year subscription, you don't pay maintenance at all on that. You're just paying the $300 annual.
Right, right. So each year, if you wanted to renew the annual academic license, you'd pay the cost as listed, $300.
Mm-hmm.
Whereas with so with the 5-user network, it would be $2,600 year 1, and then $260 in subsequent years. Whereas if you'd had a subscription amount for that, it would be I should have chose the middle one. It would be $1,500 for the first year, and then $150 in subsequent years. But if you had the subscription, it would be $300 just yearly. And so at some point in the future, the cost would cross.
Sure. Yeah. I mean, if somebody wanted to just maybe for a year or two use PSIM, I would say the subscription would be the way to go. It's more cost effective to start off with. But then if you're investing in a software for your research group or for teaching every year or for any other reason, if you're going to have it more than a few years, the best option would be the permanent license. And again, you own it forever. So you can renew the maintenance or not, but you still have the software with a permanent license. You just, if you didn't renew the maintenance.
Even if there's a software update and you
Right.
don't update, you can still use it as it used to.
Correct. Yeah, you can still use the software. You just wouldn't get like the newest version.
As you know, as a general rule, when we're doing webinars, I save the files for webinars in the latest release, and I don't save them in old releases. So if you didn't have maintenance, if you didn't have the latest version, you wouldn't be able to use webinar files or example files, you know, as they get updated and improved over the years. So you'd be stuck at whatever set of files you had. So it's one thing to consider too.
And if you upgrade to a new license, can you still also use an older license? For example, if you want to recreate some of these simulations of a webinar that was used with an older license, is that possible?
Yeah, so we allow, so we have listed on the website, there's a page where you can download all the way back to, I think, version 8 or version 9 of PSIM. So every stable release in between there you can download, and you can have multiple versions of PSIM installed. So I have beta release PSIMs on my computer. I have this current stable releases. I've got the trial license. I've got the demo. I've got a couple older versions installed as well. So you can have multiple versions of PSIM installed. And then if I open one, I'm only using that one. I'm not using multiple seats if I open up more than one. So if you had a network license and someone wanted to have 2 simulations open in different versions, they would be allowed to do that, and it wouldn't count against. You would only use 1 seat on your network license that way.
Ah, that's interesting. All right, cool. I think if there's not any other questions from our audience, I guess that means we did a good job in explaining things today. And yeah, I guess then we can wrap up today. Thanks everybody for coming and watching our webinar. Thanks Shannon and Albert for enlightening us about licensing and technical details of our products. We value your time, and we know you're busy, and yeah, we really thank you. We hope you got a good understanding of the options regarding the use of PSIM in your classes and for your research. And please don't forget to follow us on LinkedIn and the other social networks, because also there you will find links to all of our webinar recordings and other interesting content like tutorials and other cool things. And you can always stay up to date with our educational as well as product update content. Also, I want to mention this Thursday, we already have our next webinar, which is called Phase Shift Full Bridge Simulation with Code Generation and Hill. And I think this is going to be also pretty exciting, especially if you're interested in code generation. And we will use the Typhoon Hill 604 also to validate our results at the webinar. So if you're interested, please come by. If not, yeah, keep your eyes open for other webinars that are maybe more interesting for your application. And with that, I want to say goodbye. Have a great day. Please contact us with any questions. If you want to contact Shannon for quote requests or other questions, you can do that at sales@powersimtech.com. And if you have technical questions, you can always contact our support at powersimtech.com, or email Albert directly if you follow him on LinkedIn, or if you have his email address already. So it's always good to follow us. And also Albert and I, we have like a little competition of who gets the most followers. So so yeah, with that, thank you so much, and have a great day, and we'll see you at the next webinar.
Thank you.
Bye-bye.
Bye-bye.